Going to explain experiment 11 in visual learning. The topic is implementation of K-means clustering for customer segmentation. First of all, clustering means grouping similar data types together. This is called as clustering. So, this is a code. First, import pandas as field. Pandas is one of the library function in Python. So short form we call it as PD. So it is helpful to handle data sets in Python. And next, import matplotlib.pyplot as PLT. So PLT is a short form for this. So this is used to was very helpful for plotting graphs. That's why we're using. Next, data equal to pd dot read underscore CSV. We're using a data set called mal underscore customers. It reads the CSV file. We named it as data. Next, data dot get. This line helps to show the 5 rows related to the customer details, customer ID, gender, age, annual income, etc., spending, etc. Data.info, info means information. It gives information of the number of rows and columns, data types, null values, etc. Next, data is null. This line values the missing values and calculate the null values. Example, customer ID, gender, age. Next, from sklearn.cluster, import k-means. It imports the k-means algorithm from sklearn.cluster, which is also a library function in Python. Next, to WCSS. So WCSS means within cluster sum of squares, it creates an empty space. It measures how a data points close to the center cluster. Next, we are using a loop for loop. It ranges from 1 to 11. It runs the loop from 1 to 10. Next line, k-means equal to k-means. We got some of the parameters. N underscore clusters equal to I, initial equal to k-means. N underscore clusters represents number of clusters. Initial equal to k-means. This represents centroid in cluster. N underscore initial equal to 10. It runs the loop 10 times for receiving a best result. Next, we are entering into ilog. Data.ilog means it selects annual income of the cluster, customer, and spending score, this and all. It starts from the index 3. That's why it is index 3. So WCSS.append. Append means it adds the line to the end, things, some data to the end. K means dot inertia underscore. So WCSS, I have already told, creates an empty space. Next, PLT. PLT.plot means it plots the graph from range 1 to 11 WCSS. So it labels first x-axis represents a number of clusters and y label WCSS. And here the title elbow method. So it creates the graph like this. So here the x-axis represents number of clusters, y-axis WCSS, and we are using a method called elbow method. So here is the graph. Next, k equal to k means n underscore clusters equal to 5, n initial is equal to 10. So it creates to find k means model with slide clusters. Y underscore predicts, it predicts the y values, right? See here, it predicts the y values. Stores result in y. This command means it stores the y values. Next, data cluster is equal to y predict. DFC, it represents, next, it represents a cluster names. Data stores all the customers belonging to cluster 0, DF0 represents. It stores all the customer details belonging to cluster 0, and DF1 means it stores all the customer details belonging to cluster 1 as plus 2, cluster 3, cluster 4. PLT, your PLT represents plotting graph. Scatter DF0, first annual income, spending score 1 to 0, which is in color red. See, this is the red color. This represents DF0. It plots customer 1 or the Plots cluster one clusters, which is in red color. And next, it plots customer 2 details in black color. And next, it plot in customer 3 details in blue color, customer 4 details in green, and customer 5 details in magenta. So finally, these are the data points. These are the clusters, similar clusters grouping together. So here's the output. Applications of clustering. Clustering is used in many fields, marketing and customer segmentation. This is one of the application of clustering. Image processing and computer vision, healthcare, bioinformatics, social network analysis. It is also used in a medical field. Fraud detection, document and text clustering, recommendation systems, geographical and spatial analysis. So these are the applications of clustering. Thank you.